Hello, let's continue our Sudoku adventure with Whorl-A-Girl by Jean. So we have normal 6x6 Sudoku rules. That means in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have these blue lines in the grid. These are region sum lines. The way these work is when they cross a bold region border, they create a new segment. So this would be maybe the green segment, and then we could call this the purple segment, so we have names for them. So each segments on the same line have the same sum. So if this was, for example, I don't know, 5, 6. 5 plus 6 is 11. And so because green adds to 11, purple also needs to add to 11. So we could do, for example, 1, 4, 6. Sorry, yeah, that also adds to 11, right? So that'll be one way to fulfill this blue line. Probably not the correct way, but we'll see. In addition to that, we do have quadruples. So that's these circles with numbers in them. The circle always touches 4 cells. That's why it's called a quadruple. And within those 4 cells, we must have at least one each of the listed digits. So we must have a 5 in one of these 4 cells, and we must have a 6. Not just or, but and. We need a 5 in here, and we need a 6 in here. We need a 2 somewhere in here. We need a 5, at least one in here. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. All right, is there like an obvious place to start here? I think these two are the same digit as each other. We'll call that green. Why do I know they're the same digit? Well, it's just the region sum line doing that. So the sum of this is the same as the sum of these two, which is the same as this. We have something similar up here. Now we know it's not green because it shares a box. So this is purple. And actually green is on this line. So one conclusion we can make right away is that green is less than purple because green plus something equals purple. So green is at least 3. This could be 1, 2, adding to 3. So green is at least 3, but it can't exceed 5 because it has to be smaller than purple. And so then purple has to be bigger than green. So it's 4, 5, 6. All right. What can I do with all that? We know there's a 5 and a 6 in here. Now, where does the 6 go? Because we can't put a 6... Yeah, we can't put a 6 on these sums because what are we going to do? 6 plus something equals a single digit. It's not going to work because these all involve single digits on the lines. And so this is the only place for 6 in this quad. Now the quad needs a 5 and we can't put a 5 on here because remember green maxes at 5. So the 5 goes on here, which immediately tells us that this has to be a 6 and this actually has to be 1 plus 5 equals 6. And that tells us that green has to be the 5 because it had to be one of those two. And then this is, we can't use the 1 plus 4 to add to 5, so we have to do 2 plus 3, and then the 4 ends up here. All right, we just got some good digits. This column is down to 2, 3, 4. This can't be the 2 because the 2's over here in this quad. It means the 2's down here. 2 6s look down, putting a 6 here. Anything else I can do in here? I don't know. I feel like I should look elsewhere. We just got these 6s, so maybe that did something. What about 6 in this box? Well, the problem is that we have double sums here. So I don't think we can do that quite yet. We know there's a 6 down here somewhere. Any reason to believe? Oh, right. This 6 looks down. This 6 looks in. So 6 is on this sum here. Oh, this 5 looks in here. And because I was looking at this quad needing a 5. But it can't go here. So the 5's on one of these two, which means it's on this sum. So this is a 3 versus a 2. So what we want to do is think about what is the biggest this can be and the smallest this can be. And that tells us degrees of freedom. So the biggest this can be is 4, 5. That's 9. I do believe 4, 5 is possible, adding to 9. The smallest this can be is 1, 2, 5, which adds to 8. So we add to 8 or 9. If we added to 9, we'd be exactly 4, 5. If we added to 8, we could be 3, 5. We can't be 2, 6. So this is always a 5, I think. We add to 8 or 9. 8 is only 3, 5 because 6 is gone. And 9 is only 4, 5 because 6 is gone. Yeah, that makes sense. So this is always a 5, and that's the 5. So that's 1 and 5. Now, these two add to 3 or 4. So they must include the 1. So this is a 1. And then this is 2 or 3. In order to be plus 1 to get to this. The reason I know that is these 5s cancel each other out, right? In the sums. And so the 2 remaining add to this guy. So we know where the 4 goes in this row. It goes right there. Okay, so we know what this sum is then. Oh no, we don't quite know what the sum is. It's either 8 or 9. 8 or 9. Let me keep that corner marked 6. So let's look at this. This is 2, 3, 4. See, we got our 5. I don't know if I care about the 2 at the moment. We got our 5 and 6. I don't think it's the quads at this point. It's German Whisper, or it's German Whisper. It's the region sum, or it's Sudoku. We can place this 5. 5s are done. What about 4s or something like that? 4 is one of these two. One of these two. So this is either 2, 3 or 3, 4. This is 2, 6 or 3, 6. And this is 2, 3, 4. So, okay. We're either going to add to 8 or 9. So this could definitely be a 6. Can't be a 5. It could be a 4. No, can it? Okay, so if this was a 4, the biggest we could do is 3, 4, which is 7. And that's too small because this is 6 plus 2 or 6 plus 3, which is 8 or 9. So this has to be a 6 because it can't be a 5. That places the 6 here and places the 6 here. 2, 3 pair gives us the 4, which comes back down to give us the 3 because of how the sum works. These have to add to 4. That's 2. So this adds to 8. And so then this is 2. Yeah. These are the same digits. These are the same digits. Very nice. That's 3. That's 4. The 2 is placed in the column. We get the 3 and the 2 here. Alrighty. This is 1, 3, 4. Oops. Sorry, the 4 extends. 1, 3. We know the order. That's 1. That's 3. That's 4. Over 3 in the corner celebrating. Over here we need a. This is the 1 for the column. Oh, we can get the 3, 4 up here. We can just finish the whole puzzle. This is 3. Up here we need a 1 and a 2, which isn't resolved yet. And over here we need the 1 and the 2, but this 1 tells us the order. So that's 2 and 1. 2 and 1, and this is 2 and 1, and we're done. All right, neat puzzle, Gene. I think that yeah, thinking about this sum versus this sum actually was very fruitful once we got this 6. That really limited it. That seemed to be the crux of first of all, thinking about the 5, 6 here. Was it the 5, 6 here? Thinking about the equal digits and how they related. That was neat. And then having to come over to the left side and thinking about the maximizing this versus minimizing this. All right, cool. Well, let me know how you did. And if you enjoyed this, why don't leave a like, subscribe, and a kind comment below.